blogging, so you guys can follow me on my website. That's called ncpatro.com, which is my name also. So today we are going to understand what are the essence of reactive programming. So before even understanding what is reactive programming, we should understand what is asynchronous programming. So to even before going into that, we'll go to a movie to understand this, because we had very cool things we have already learned. Let's relax a bit. So let's try. So how many are Marvel fans here? Awesome. I can see a few hands. And I'm an Iron Man fan. How many here are the Iron Man fans? Awesome. Lot of Iron Man fans.
Round in 5, 4, 3, come on! 2.
This is pretty bad.
How did we get this shift?
All right, I'm gonna give you a chance to escape. Put down your weapons. Tie yourselves to those chairs. I'll let you live. In 5, 4, bang!
Wow, that was...
You should be gone by now. You should already been gone.
I am just beyond terrified.
Here it comes.
It's my bad.
3, 4...
Shut up.
5, 4, 3, 2, 1.
Told you.
Okay, so we could not see it, so I'll try to explain. So this is a shot I have taken from Iron Man 3, where he trying to escape, and his suit is not with him, and he is saying 5, 4, 3, 2, 1. So he's calling something, and part of his suit starts coming. It comes one by one, and in the meantime, if you see, he's not waiting for his suits. He's doing some job. That's an action. He's fighting with the villains. And at the time, one part of the shoots are coming. So guys who have seen the Iron Man 3, they might be familiar with this. And the shoot came, and he's still fighting. I think now it's pretty good.
Where's the rest?
Where is the rest? He's still waiting for the rest. Okay, so the intention of this was, so now we'll come back to our asynchronous programming and how this video is related to that, right? So what is asynchronous programming? So asynchronous programming is, in JavaScript, is something like this. Let's say set timeout. And you say a set, so here what Iron Man was doing, Iron Man did a call to his suit, and his suit is coming, flying, and in the meantime, he is not just waiting for the suit. He is doing some action, he is fighting with villains over there, and as soon as the suit part are coming, he is acknowledging those, means he is processing those. So that's what exactly the JavaScript also do, right? JavaScript doesn't do that. So if you see this program set timeout, which is a native JavaScript function, where we say, hey, set timeout, you execute this, and after certain time interval, where it is 1 second, you print this console log async. And in the meantime, how JavaScript does? JavaScript execute this function, which is set timeout, and it doesn't keep quiet for a second, right? It goes and do some other job. Maybe some button click have happened, maybe some mouse movement has happened. It has to react to those. So it do that, and then when 1 second is over, it comes back and prints this console log. Similar how we saw Iron Man was doing. He was not waiting standalone when his suits were flying and coming. He was doing some other job as well. So that's what asynchronous programming is. Asynchronous programming means, and callback, what I'm showing here, it's a callback. So there are a different flavor of asynchronous programming, and callback is one of that. And callback is nothing but continuation, right? So if you see the previous, the small code snippet, so this is like continuation from it where it left. So first callback is like it executes the first half of the program and then executes a later half of the program after certain time interval. And that's a one kind of asynchronous pattern that's called callback. So there are more asynchronous pattern, and the second asynchronous pattern which is pretty popular is promises. So callback was there, lot of application has used callbacks for decades in JavaScript, and now then the promises came. And then why promises came and why not, so what was the problem with the callback? So callback was having a problem of trust issue. So if you see in callback, so if you remember that example, set timeout, so set timeout is a method and we are just passing a function to that, means we are passing a trust, and then set timeout decides after 1000 milliseconds what function it to execute. So I am just passing a function from my function to a set timeout. So now let's say there is so now you replace set timeout with some vendor function, and then you're passing something to the vendor function to get executed after certain time interval. So means there is a trust issue. Let's say tomorrow the vendor function which is there, instead of calling it once, called it 5 times. Let's say it's an retail app and your credit card got debited 5 times. So that's the issue of a callback. That's basically a trust issue which promise resolve. And how the promise works, so I read it recently in one of a book called You Don't Know JavaScript. There's a very good example to understand what promise is. Promise is like you move to a ice cream parlor or let's say a coffee shop, and then you say, I need cold coffee. What a waiter does, he gives you a slip. He doesn't give you a cold coffee immediately, give you a slip, and that slip is nothing but a promise to get a cold coffee after some time. Then we waited for some time, and then we go back once our coffee is ready, we go and give him a slip back and collect the coffee. That's exactly a promise is, right? So we call to a function, let's say call to an API, then the JavaScript do its own stuff, and whenever the promise returns, I get the data and executes. So that's the fundamental difference between callback and promise, and these are the two patterns of asynchronous. And then came the generators. Generators are a new function which has been introduced in ES6, and that function is pretty special. So if you think of any function, once your function's execution starts, it only stops when it reaches to the last line of return, right? That's what the exact behavior of a function. But a generator functions are a bit strange. You can tell them you can stop at this line, restart it again after some point of time. So that asynchronous coding, you can do it in a synchronous way using generator. So generator is also a pattern to do asynchronous programming. And then comes the observables, which is mostly used now with the current structure, and we're going to learn that what these observables are. So before even learning observables, let's understand what a reactive programming is, right? That's the topic of today, reactive programming. So if you see this Excel sheet, how many love Excel sheet? I think no, yeah. So Excel, as a developer, no one loves Excel sheet, but all agrees Excel sheet is wonderful of doing a lot of things, right? So if you see, this is an event planner. So if you see, if I change the row number 3, that is basically an input, all these row number 4, 5, 6, 7, all get changed because there is some computation logic to calculate the values, right? So that's a reactive programming. So you change. So you have row 4, 5, 6, 7 is already ready for any changes which will going to happen on row number 3. So if I change a row number 3, invitation sent to 1, 5, 4, 6, now you see a different value in each of those columns. Similarly, if I change a value 4, 5, 6, 7, so based on new values, I get a new output. So based on new input, I get a new output, and this output, as soon as I change in Excel sheet, I'll get it. Maybe we'll see it very fast, but it must be doing behind the scene, it must be doing that calculation and getting the value. So that's exactly a reactive programming is, right? You change your input and all your output reacted to that. So that's a whole about reactive programming, and how we'll correlate this to our JavaScript world. This reactive programming is, so I've taken this wiki and that's what we saw, right? Reactive programming is a pattern oriented around data, streams and the propagation of change, and that's what exactly happening here. Once I change the data and the data is propagating, so what I'm saying here, invitations send 1,000, let's say if I send an invitation to 1,000 guys, 80% will register, out of that 80%, 90% will turn up, out of that 90%, 80% will have food, and out of that maybe 40% will have non-veg, and I know how much non-veg or a veg items I have to arrange. So this is nothing but the propagation of data happened as soon as we change a data stream, and data stream is here a different data. First data is 1,000, 1546, 4567, 15800, but my logic is ready to handle those data streams. And reactive programming is nothing is that. It's a pattern oriented around data streams and the propagation of changes. So now let's come to our web application coming out of Excel sheet. So if you see, this is a typical web application where you'll have a client, you'll have your JavaScript code, we'll have backend services, and obviously everything happens against time. So if you see in client, some mouse click happens, some render happens, some mouse movement, button click, there are a lot of event happens in any of the web application, and your code, the JavaScript code has to handle those events, and the code has to be already there to handle all the event continuously, because this will happen continuously. There could be mouse event, there could be render event, there could be a button click, there could be, and once happens that your JavaScript code decide, oh, okay, based on this button click, I have to hit a backend service to get the data, form submit happens, I have to do a create record in the backend service. So all this, if you see, it happens in a timely fashion. So each time this happens, and this is what exactly a reactive pattern. So my JavaScript code, if I'm following a reactive pattern, it's already ready to handle those events. I don't have to create a new instance every time for these all events. So these are events are nothing but a stream of data. So I'll go back to this. These are events now you can correlate with. These are like data streams, and I have a code to propagate the changes, because I know which event I have to do an API call. When API respond, I have to back to render the client. So these all we generally do every time on our mobile application, web applications, and it happens. So now we understood what asynchronous programming is, how it has evolved from callback, promise, generators, and now we came to observables. And why I'm talking observables, as of now I have not mentioned anything about observables, we'll understand that in a bit. So now we understood what a reactive pattern will look like in actual application. So now come a reactive extension to handle this. So there is a library called reactive extension, which is nothing but an API for asynchronous programming with observables patterns. And observable is nothing but it's a data stream. So there are API to handle a continuous data stream in our application, because if I go back to this, when these things are happening, obviously our JavaScript code is not waiting. So it's not waiting for a mouse event to happen and just not waiting for another mouse event to happen. It has to do a lot more thing behind the scene. At the same time, it might have to do an API call. Same time, it has to execute whatever the response is got. And then the event happens, suddenly I have to react to that event. So to handle these kind of programming seamlessly, reactive extension is a library which offers something which we can do very easily, the asynchronous programming. So RX, so reactive extension, a library by Microsoft folks, and they have lot of versions. So you have RX Java, you have RX.NET, you have RX Python, you have RX JavaScript. RxJS is a JavaScript library for you. So they have bunch of library, and the behind the scene, the core is reactive extension. That's called Rx, and that's how the RxJS, RX Java, RX Python all has come up. So RxJS is a JavaScript library of ReactiveX. So ReactiveX is based on observer pattern. And what is an observer pattern if the question comes next? Okay. So observer pattern is a design pattern in which there will be a subject, or which is basically an object, which is called a subject, maintains a list of its dependencies called observers and notifies them automatically when the state changes, right? And if you see, if you remember the Iron Man video now, it's same. So you think of he maintains, so he calls this, and then automatically all the data flows. Data is nothing but a part of his suite, and is able to handle those, right? So this is exactly the observable pattern. Is anytime any button click happen, any mouse event happen, I should have a code ready which can, which like I know who all are observing for those an event. Let's say a mouse event happen, I will have 10 methods who are looking for that event, and those 10 methods can get executed. So observe pattern is exactly that. So some folks has been waiting for a guy called subject to emit some data. As soon as they emit an data, I can handle this. So that's exactly a reactive acts behind the scene. This is a pattern which works. And if you see the code, so without code, it's, so I don't prefer to talk without code, so that's why let's code. And in the code, if you see, this is one of the simplest way to look for a button click event. So if you see, this is just a few lines of code, and I'm using a RxJS, is nothing but it's a library, so you can use it. You can download as an npm package, and then you can say import. So I'm using a form event, and you can see where observable. So I'm creating an observable. Observable is nothing but a source of data. You can understand source of data which can lazily sends data. I'm saying lazily because it depends on what event happens when, and as soon as the event happens, it can emit the data. As soon as it emits the data, you can see that in the line number 5, we have subscribed for the data. So I'm saying line number 5, observable dot subscribe, and as soon as the button got clicked, my line number 6 will get executed, button clicked. And anytime you click that button, how many number of times, I'm not doing anything else, every time this line number 6 is going to get printed, right? And this is what exactly the observable pattern is, and this is RxJS based on that observable pattern. And you see, it's very, very simple to execute. And if I see a little complex code than that, so in this code, if you see what we are trying to do, same, we have a document.click. So anywhere in the document, if the click happens, I want to know which is the x coordinate, and I'm just summing all the x coordinates. This is what is happening. So again, I'm creating an observable. Observable is nothing but it's a source of data. Anytime the data is available, it will emit it. And line number 6, if you see on that data, I am doing some manipulation based, or I'm putting some logic, because the data can be lot, but I can decide what kind of data I need. So whenever the click has happened, I'll have lot of data regarding that event, but let's say I just interested in a coordinate x of that event where the click has happened, and I'm putting a throttle time. So these are all our inbuilt methods, throttle time. So I'm saying I don't want to data bombarded with me. I'll take a new data every time after 1000 milliseconds. That's after 1 second. If any click happen, I'll take that. So between 2 clicks, I'm giving a gap of 1 second, and then I'm taking event.clientX and I'm just adding it at line number 9, and then a subscribe. I've subscribed to it. So anytime a click has happened, then it will pass through this logic, and then I have subscribed, and the count will get increases, right? So that's how your subscribe and observable pattern works. So you will have an object, and there will be a guys who has subscribed to it. Anytime data changes, you will get notified. So that's about RxJS. So if you see a building blocks of RxJS, observables, what I have mentioned, observables nothing but a source of data, right? And you can create observables using RxJS. Operators, so if you see the operators are nothing but methods. There are 2 kind of operators, one about transforming your data, one about creating the observable. So if you see in this previous my code snippet, form event is nothing but an operator by which I have created an observable, and pipe, throttle time, map, scan, everything is nothing but operator by which I can transform my data. And then the third block is subscription. That is, so subscription is a function by which you can subscribe and unsubscribe to that observable. And then comes subject. So there is a very minimal difference between an observable and subject. Subject is nothing but a special type of observable where a multiple guy can subscribe to a single object, and in subscribe in observable, it's just one guy can subscribe to it, and then a scheduler. You can decide when you want to schedule your observables to emit the data. So these are the 5 building blocks of RxJet, and you saw how easy it was to implement asynchronous programming using RxJS, and which is very widely popular currently doing asynchronous programming. So there are callbacks, promise generator, everything is there, but observable is super easy to implement it. So as of now, observables are there as a library. It's not part of native JavaScript, but there are discussions where it might be part of native JavaScript in maybe next JavaScript versions. So it's just not an end of learning of RxJS. So there are a lot of resources to learn that. So you can go to the Reactive IO, but my favorite website is rxmarbles.com. So I'll just give you a glance of that. So this is a very good website to learn anything. So there are a lot of methods are there. So if you're thinking what this guy is doing, so if you see, if I open anything as map delay, so if you see, so you can see this is any data which is, so it just, you're giving on 1, the output is 1, so map is doing that. So if I do to delay, so you can see delay is 20 seconds. So if I can bring this data, you can see this data is coming here. So you can play around how your methods will work. So there is something called count. So you can see this is anytime x is greater than 3, then only you print it. I can move it here. I can see when data will come. So this is a very good website to learn what all other methods Rx library has and what is exactly, because when you read a documentation, sometimes it will be boring and it takes its own time to understand. But here it's pretty fast and interesting to learn all its method, how it works. And then whatever the code snippet we saw, we just execute that. So this is what I mentioned. So anytime a click happen, I'll just sum it. So if you see a click happened, the sum happen of the client text. And if I do continuously, it just captures once because I have this throttle time. So it just throttle it for 1 second and then only take the second output. So this is all can be doable and observable. Observable is a very good, Rx is a very good library, and or you can create an observable, and on top of that you can transform your data, you can change your data, and you can subscribe to it. That's the entire pattern of RxJS. And yeah, so that's all what I have. I'm open to the question. Okay, so previous slide, this one. Oh, so I have not put it that because it comes somewhere with generators only in the ES6. Yeah. Oh yeah, scheduler. So scheduler, so the question was something on scheduler. So scheduler is something you can decide, let's say you have an observer, so you can decide how frequent it should emit the data, and also that you can configure using a scheduler.